Hi there, it is Trombley again. We're on lesson 10-2, solving equations again, but this time we're going to have variables on both sides of the equations. With the equations that we did in section 10-1, we had multiple variables in there. However, they were all on the same side. When they're on opposite sides, it changes things just a little bit because you can't combine like terms like normal. So we're going to work on that. To solve an equation with a variable on both sides, basically all you're doing is you're collecting all the variable terms on one side and all the constant terms on the other side and using all of the things you have learned so far to finish it up. So I have again a nice little checklist for you here as you're going through each problem that if you're confused about the steps, having these notes in front of you as you solve each one could prove to be very helpful. Step 1 is still the same as yesterday, so is step 2. We're going to get rid of any parentheses that we see by using the distributive property, and we can combine like terms on either side of the equal sign. I can't cross the equal sign when I'm combining like terms, but I can combine them on either side. Finally, we are going to add the opposite of one of the variable terms to both sides of the equation. So I know normally after steps 1 and 2, you'd be used to getting rid of whatever's being added to the variable term. Now we're going to choose one of the variable terms to kind of cancel out from one side and move to the other. At that point, steps 4, 5, and 6 are going to be exactly the same as the 1 and 2 step equations you've been working on all year long. So let's just try some. I think the examples are really what helps here. Okay, I'm going to draw my line. Step 1 says to remove any parentheses. Well, the good news is there aren't any. Step 2 says combine like terms on either side of the equal sign. So on this side of the equal sign, I don't have any like terms, and on this side of the equal sign, I don't have any like terms. Good. Step 3 says add the opposite of one of the variable terms to both sides of the equation. Okay, so I have a 3h here, and I have a negative 2h here. Remember that it's your goal to have all the h's on one side and all the numbers on one side. So what I would do here, and honestly guys, it doesn't matter which one you choose to move, but I would get rid of the 3h from this side so that I automatically have all my h's on that side. So here's what I mean. I want this 3h that's being added to move over there, which means I want to cancel it out from here. How do you cancel out a number that's being added? You add the opposite of it. So I know you're very used to dividing by 3 when you see something like this, but we're not going to divide by 3 because then h is still left on this side. We want to cancel it out completely, and the only way to cancel things out completely are to add the opposite of them. So I'm going to add a negative 3h to this side. I'm going to add a negative 3h to this side. When you take 3h plus negative 3h, it's 0. That means you're left with 10 on this side. Now I have negative 2h and a negative 3h. Those are like terms. I can add them. A negative 2h plus a negative 3h gives me negative 5h. I'm hoping that you recognize this is just a little one-step multiplication equation. All I have to do now to isolate the h is divide by the number it's being multiplied by. So after you divide, h is left, and 10 divided by negative 5 is negative 2. When you check this, you actually have to plug in 2 separate amounts into your calculator, if that's what you're using. So I would end up doing, let me get a darker pen here. 3h plus 10 is supposed to equal negative 2h, so I need to take 3 times negative 2 plus 10, and that should equal negative 2 times negative 2. So I would solve this side. 3 times negative 2 is negative 6. Negative 6 plus 10 is 4. And on this side, negative 2 times negative 2, that's also a positive 4. That means that we're right. So again, when you go to check these, you're plugging in 2 separate amounts to make sure that they're equal to one another. You solve one side of the equal sign, solve the other side of the equal sign, and see if they match. If they don't match, it means you need to go back to the drawing board and see where the mistake happened. Alright, next example. I'm going to draw our line down the middle. I see that there's some subtraction here, so I'm going to go ahead and keep change that. That's kind of like saying negative 1y, right? Okay, again, if my goal is to have all the letters on one side and all the numbers on the other, this time I think I want this y to go over here so that all the y's are together. So I want to cancel out this negative y completely that's being added. To do that, just add a positive y. And whatever you do to one side, you have to do to the other. So a negative y plus positive y, gone. I'm left with this 9. Negative 4y plus y, again, please remember, this means it's a 1y. So I'm taking negative 4 plus 1. That's negative 3y. Again, we're left with a cute little one step. It's so cute and easy. Divide by negative 3. Don't change your signs. And y equals negative 3. Again, to check it, I would say negative 4 times negative 3. That's 12. 9 plus, and then this means the opposite of y. So this would be like 9 plus the opposite of negative 3. What's the opposite of negative 3? Positive 3. Is 9 plus 3 12? Yes. And negative 4 times negative 3 is 12? Yes. So we know that we're right. Alright, moving along. It's the last one like this. They get a little bit harder each row as you go. So I see there's only this one term over here, and over here I have an x and a 12. I want to move all my x's on that side. So to get rid of this x, I'm just going to add a negative x. That's how you cancel things out. You add the opposite of them. X plus negative x, gone. 12 equals, okay, this is negative 5x, and this is really negative 1x. If you don't see a 1 in front of the letter, it's really there. It's just hiding on you. Negative 5x plus negative 1x, that's negative 6x. And again, there's, aw, so cute. My little one step. I'm going to divide by negative 6 to isolate that x. And 12 divided by negative 6 is negative 2. Alright, so with those ones, they all had something in common. They all had just a variable term on one side by itself. And all we did was we moved the other variable term to that same side and ended up with a cute little one-step equation. With the next row, I'm hoping you notice the difference here. I have variables and constants on both sides of it. Steps are still going to be the same. We're just going to have to add another one in there. So I'm still going to draw my line. I'm going to change all of my subtraction to addition by adding the opposite. Okay. I do not see any parentheses. I do not see any like terms on either side. So we're on step 3 right now that says add the opposite of one of the variable terms to both sides of the equation. So the variable terms we're dealing with are negative 4y and y. What you have to do now is pick which one of those do you want to move. I personally like to choose the one that when I add it to the other, I get a positive amount. It doesn't really matter which one, but I would choose to get rid of this negative 4y. To get rid of this negative 4y from this side, to put it over there, I can't just add those together. I have to cancel this out from this side first. So I have to add a positive 4y to each side. When you do that, those cancel out. 15 is left. On this side now, I need to combine like terms. I have y's. Those go together. 1y plus 4y is 5y. Plus, I still have that negative 8. It didn't go away. Do you recognize it now? All this is a two-step equation. So I'm going to isolate the 5y first by getting rid of the negative 8 that's being added. And I just add a positive 8. Those cancel out. I'm left with 5y here. And this is just 15 plus 8. Isn't that nice? There are no negatives, nothing. I just get to add like normal. It's 23. It's okay that there's a 5 and there's a number that doesn't end in a 0 or a 5. You'll be alright. I'm going to get rid of the y by dividing by 5. And y is equal to, when you take 23, you divide it by 5, we get 4.6. Y is allowed to be a decimal. Decimals are allowed. Treat them kindly. They're numbers too. Alright, next one. Let's try a couple more of these. It's going to take a bit, so if you're not understanding, don't feel discouraged. We've got plenty more examples, and we'll be doing some things in class also. Draw your line, add the opposite, add the opposite. Okay. When I look at this problem, I have to ask myself, would I rather take 4 plus negative 6 or 6 plus negative 4? I personally would rather do 6 plus negative 4 because then I get a positive number in front of the b and I'm less likely to make errors with those negative signs. So I'm going to add a negative 4b. because I had no parentheses or like terms to combine in this. The b's are gone on this side. I'm left with negative 2. I can combine these b's together. 6b plus negative 4b is 2b, and I still have my negative 4. Again, 2 steps. Remember when 2 steps seemed hard? And now you're probably like, yes, it's a 2-step. I know this part. I'm going to add 4 to each side. Negative 2 plus 4 is 2. On this side, I'm just left with 2b. Now all that's left to do is divide by the 2, because it's in front of the b. And b equals 1. Or 1 equals b. Reflexive. Either way, doesn't matter. Okay. 9 minus n equals n plus 5. Okay. We need to keep change that. I had the opposite of it. Now, this looks kind of tricky because there are no coefficients written down. So if I were you, I would just put 1s in front of those. It's a little less confusing. Right now, I don't have any parentheses. I don't have like terms on either side. So that means I need to add the opposite of one of these variables here. Now keep in mind, here I'd need to add a positive 1n, right? So I'd be doing 1n plus 1n. To get rid of this, I'd have to add a negative 1n. So I'd end up with another negative 1n over here. It doesn't matter, but like I said, I like to have the positive ones. I like to be positive, you know? It's better that way. So I need all my variables on one side. I'm going to get rid of this negative 1n. I do that by adding a positive 1n. Those are gone. There's my 9. 1n plus 1n. Yep, that's 2n. Plus 5. There's our 2-step. We are at the home free point. Yay! Right, get rid of that 5. Add a negative 5. Over here we're left with 4 because 9 plus negative 5 is 4. And here we're left with 2n. Almost. We're at the cute little 1-step time. Divide by 2. And yes, n equals 2. Voila. Alright, last row. I told you they're going to get a little bit harder as we go. It's alright. We'll work through them. You'll get it. With this, okay. Yeah, we've got some parentheses now. But that's alright because you are now a champ at getting rid of them. We know we have to distribute the number on the outside to everything inside first. That's our step 1. So 2 times 7x, that's 14x. Bring down the addition sign. 2 times 3 is 6. And over here, there's nothing to do. Now this looks like that first row that we had. Remember, it's your job to get all the variables on one side together, right? So if this side only has a variable on it, I'm going to ignore my whole positive negative rule for this one. And I'm going to cancel out the 14x so that I'm just left with a number on that side. To cancel out a 14x that's being added, to make it go away completely, I don't divide by 14. I add a negative 14x. Because that's how I get rid of things. Adding the opposite of them. Plus 6 is left. That means a positive 6. And now I need to take 6x plus negative 14x. When you take 6x plus negative 14x, these digits, I'm going to subtract them and take the sign of the greater, because that's what you do when you have one of each. So you end up with negative 8x. Alright, now all I need to do is divide by negative 8, and I'll have x by itself. Those cancel out, and x equals, when you take 6 divided by negative 8, we get, I'm guessing you're going to use your calculator on this, so I'll write the decimal version. It's 75 hundredths. If you just looked and said, oh, that's 6/8, maybe you wrote negative 3/4. Either one is correct. They mean the same exact thing. It's up to you. All right, next one. Ooh, a couple sets of parentheses here. So I'm going to draw my line. Keep change. Step 1 says get rid of parentheses on either side. So negative 5 times 4x is negative 20x. Negative 5 times negative 2 is 10. Negative 2 times negative 2 times positive 3 is negative 6. Negative 2 times 6x is negative 12x. All right. So now we have an equation that's kind of like that second row. I have variables on either side here. It doesn't matter which one you choose to cancel out. And I know I always go with I want a positive answer. But this time I'm just going to go with, I'd really like my variables on the left. I know Mrs. Sullivan really likes when her x's are all on the left side of the equation. So this is for you, Mrs. Sullivan. All right. I want negative 12x to cancel out. I want it to move. So I'm going to add a positive 12x to make those go away. On this side, negative 6 is left. On this side, you can combine the x's together because those are like terms. So you have negative 8x plus 10. Yay, the home free point, the two-step point. Get rid of this 10 that's being added by adding a negative 10. You're left with negative 8x on this side and negative 16 on this side. And now, yep, divide by negative 8, and x equals 2. You get a positive 2. Now, when you're checking this equation, you have to plug it into this side. So I would type in negative 5 with my parentheses, 4 times 2 plus negative 2. Hit enter, write down what I get. And over here, I would type in negative 2, open those parentheses, 3 plus 6 times 2, close them, hit enter, and make sure you get the same thing on either side. Again, we'll practice that in class a lot more. Okay, draw your line. Almost there, last one. I'm going to add the opposite wherever I see subtraction going on. I see parentheses, I want them to go away. So 8 times 4, that's 32, and I have k's. And 8 times negative 4, that's negative 32. Over here, nothing happens. It's still negative 5k plus 32. Okay, just as like the second row, I see that I have variable constant, variable constant. I want all the variables on one side and all the numbers on one side. So the first thing I'm going to do is put all the variables on one side. And I'm going to choose negative 5k. I could choose 32k if I wanted, but I'm not going to. To get rid of this negative 5k completely, that means I need to add the opposite of it, which is a positive 5k. 32k plus 5k, that's 37k. Okay, equals negative 32. Negative 5k plus positive 5k are gone, and negative 32 is left over here. Okay, this is a two-step. I'm going to add 32 to get rid of that negative 32 that's being added. And 37, it's a weird looking 7, sorry, equals negative 32 plus positive 32 is 0. It's allowed to equal 0. Zeros are allowed. Don't freak out. I'm going to divide each side by 37. And yeah, 0 divided by 37 is 0. Voila. You're all done. I'll see you tomorrow.